record this so it sounds a little better. So I opened up this NBA shot data set. So if you go up here to that very first cell and you hold Control and Shift or Command Shift on a Mac, and then as you're holding that, you can use the arrow keys and it'll go over to the very, so you hit the over key, goes to the very last variable in your data set, then hit the down arrow, it's going to go all the way to the very last observation. If you then go up to this filter button under the data tab, so click it so that it's on. As soon as it's on, you should see these little arrows on every variable pop up. So this allows us to like sort and kind of look through the variables a little bit easier in Excel. It makes life a little bit easier. So you'll notice some of these variables, we've got some missing values. So that might be a problem down the road, but we'll deal with that eventually, right? But we've got a bunch of different variables here. And so maybe I'm interested in the characteristics that are good at predicting shot success, okay? So I'll go up here, maybe I'm looking at, let's see if I kept there. Here it is. I know this is shot made previously. So I want shot made. There we go. And sometimes when you have that filter tool on, if you grab in between the columns, you can kind of just left click and adjust them so you can see the actual full name. So here I've got shot made, and maybe I'm just going to think about, okay, can I predict whether or not a shot is going to be made simply based off of whether or not the previous shot was made? So this is the idea. I think I mentioned this one. We looked at that one paper, and it was thinking about the hot hand effect, right? So how would we start to approach this? So one of the big issues is I've got some missing variables here. Well, if these are the only variables that I'm interested in, I'm just going to select these three here. So shot made, shot distance, and whether or not the previous shot was made. So I can hold Shift, and then as I use the arrows, it just selects those, goes over and selects those columns. Now to select the entire column of data, as I'm holding Shift, I'll also hold Control or Command on a Mac. And now if I hit the down arrow, oops, this is going to be a problem because I did it from the right side. Sorry. So this is the variable that's missing stuff. So when I was going down, it's just going to go to the next blank. But if I start in the variable that has everything, so Shift, hit the over arrow twice to select those variables, hold Control or the Command key and hit the down arrow, should select the entire column of data there for me. Okay. So I'm just going to copy. So right click and copy these. I'm just going to paste them so I don't mess around with the original raw data. Right? This was I said, a pretty good practice. So you're not deleting any of the original raw data if you want to maybe do a couple different regressions or a couple different ways of doing the analysis. So, if I try to run this, it's going to have an issue because Excel will just get mad that there's missing values. Right? So how can I get rid of these missing values pretty quickly? Well, once again, let's just Control Shift or Command Shift on a Mac, over and then hit down, and we'll filter this data. So if you do it this way, I'll scroll back up here. When I click on this filter arrow, notice it shows me that there's zeros, ones, and blanks. So zeros if they didn't make the previous shot, one is if they did, and then your blanks is just there's missing data. So basically this was like the first shot of every game, or if a player only took one shot in the game, or we're going to have some missing values there. So I'm just going to sort this from smallest to largest. Notice it's going to show me all the zeros first, then the ones, and it always puts the blanks at the end. So this is one way of kind of doing it. I could scroll down and then just delete those ones that have missing values. But probably an easier way is if I hit select all so that it deselects everything. And then I just want it to show me the blanks, right? So I select blanks. Well, now, right, I can select all those values that were blanks, right? So just Control Shift or Command Shift on the Mac, use the over keys. Now these are the ones I want to delete. So I'm going to right click and hit delete row. Okay. So once I hit delete row, it'll ask me, do I want to delete the entire sheet row? And it gets rid of all those observations that have basically missing values. Okay. So I'll then go back up here. Now I can see, okay, I've only got zeros and ones, which is what I wanted. Right? I'll hit select all, hit OK, right? And now I've only got makes and misses. I don't have any missing values. Yep.
When you sort it from small to smallest, does You gotta make sure you highlight everything so it doesn't mix and match the wrong.
Yeah, so when I was selecting this, I had to make sure I selected the entire data set, right? And then once I add that filter option, when it orders things, it's moving the entire observation. So it's moving every single value for every single variable in the data set, you know, with each other. So you're not, mixing everything up.
Okay.
So yeah, once you throw that filter option on, basically think about it as all Excel's doing when you order things is it's like moving the rows like this, but every single variable is getting moved, right? The whole row is getting moved at the same time.
Okay.
Yep.
So how did it know which one to move, like with the one to zero instead of the shot distance?
Oh yeah. So here it's because I selected this one, I can actually look at what the furthest shots are. Like these are like crazy past half court shots, right? At like the end of games. Okay. So I can sort on any one of these variables. Yep.
So sort it, you want to figure out which one to actually highlight it and then click whatever one you want to be sorted.
Exactly. And you can like I just did, I can sort on one, then sort on the other. So for instance, if I had something like, let me look at this one. Oh, I might have thrown out the team names here. I think I did. But what I could do is say, maybe I want to see I want to see the players. So I'll sort from A to Z so that every player is kind of sorted. This is a big data set, so it's going to take a long time to sort this. And then maybe I want to sort by date as well, right? And so I'll go oldest to newest. So I'll see the most recent. You'll see this will kind of shift around, I think, here. There we go. So that I can kind of see, you know, here's Aaron Brooks. Here was, you know, his shots on this day, and Al Horford, their shots. So you can kind of sort this by multiple variables. You just have to do it kind of sequentially. Okay. So now that I've got no missing values, and I think just a refresher, I think we went over this before, but if I go, I want to get this data analysis option added into my Excel. So on a Mac, this might be a little bit different. I believe you'll go up and it's not even like part of Excel. It's actually part of like the Mac. And there's like a tools at the very top. Then when you click on tools, you should get the same place if you're on a PC. If you go down to file options, right? And then you go to add-ins. So once you hit that tools, there should be an add-ins option somewhere there on a Mac as well. Right? And then once you've gotten to add-ins, you go to manage your add-ins. You will just make sure that analysis tool pack has a check mark next to it. Hit OK, and then that data analysis should pop up there. So try to get onto your computer, whoever you're going to use, and try to get this added in. That way, if you're having issues with it, especially if you're on a Mac, you can let me know and I can help you out with it. Right? So I don't own a Mac, so I can't physically show you, but like I said, I believe it's under like the tools at the top, and then there's some type of like a tab that says add-ins where you can select that analysis tool pack option. Okay. So if I hit data analysis and then I scroll down, there should be a regression option. Okay. Once I have that regression option selected, I can select my Y and my X variable or X variables eventually, but we'll just do a simple one right now. So maybe my Y variable is just, was the shot made or not, right? So Control Shift or Command Shift on a Mac, I can select 368,000 observations just as easily as I could 50 observations. So the size of the data set shouldn't be daunting. The size of the data set is just giving you more observations to get more accurate results. The process, like what you actually have to do, Control Shift, hit the down arrow, is the exact same if it's 50 or 50,000. So I'll then hit this arrow to send me back. And then I'm going to select, okay, I want to select my X variable. I never can remember the sequence, but sometimes it will send me to the top, other times it doesn't. So scroll up to the top here and select whether or not the previous shot was made. So Control Shift, hit the down arrow. Looks like I'm going to have some issues if I want to use that shot distance as well, because it's got some missing values in it. But I'll go back here. I selected the very first cell, which was the labels. So I want to make sure that's selected. If I don't, Excel will, well, here. Excel will get mad at me. All right, there's non-numerical values. That was the name of the variable, right? So I'll make sure I tell it I selected the labels, hit OK, and it'll spit this regression output out. Right? So one of the reasons why it's good to select the labels is because if you don't, you'll just have like, we'll say like X variable here. Right? So we've got coefficients, you've got the standard errors, you've got test statistics and p-values. Okay? So primarily what we'll use in discussing the results here are going to be our coefficients on our different variables that we included. Here we've only used one up to this point. and then our p-values. So if we remember, I don't know, talk about this since we had the exam and the spring break, but whenever I'm looking at my regression analysis, right? So here we just did, was the shot made? We've got an intercept, and then was the previous shot made was the variable we included on the right here. So every single time, what we're doing is we're assuming, and it doesn't matter, I wrote B1 here, but it could be whichever variable. If I included 50 variables on the right-hand side, we always assume that that coefficient is equal to 0. So that will be our null hypothesis. And then if we can get a p-value that's less than our alpha, and alpha is essentially just the levels of confidence we want to say things with. So if I think about my different confidence levels, our benchmark values are 95, 90, 95, and 99, which we sometimes say things are significant at the 10%, 5%, 1% level. Right? They're just kind of different ways of saying the same thing. Right? It's either I can say that it has a statistically significant with 90% confidence or 10% significance. It means the same thing. So we're really going to be looking at those p-values to see, are they less than these different thresholds? Now, alpha is basically your significance level, but in decimal form. So we're looking to see, is the p-value less than 0.1? Is it less than 0.05? Or is it less than 0.01? Okay. If it is, right, then we can reject that null, or we can reject that there's no effect. We found evidence that there's a significant effect between this X and Y variable. Okay. Any questions? And I know it's probably a little bit of a refresher from some 221 stuff, but really you're just checking to see, is that p-value associated with that variable less than any of my benchmark values for alpha? If it is, then I can say I can reject the null at the 10% significance level, or reject it at the 90% confidence, with 90% confidence. So what was our actual p-value here? Let's see, 0.0006. So very small. It's going to be less than every single one of those alphas. We would say, even at the 99% confidence level, we can reject the null that there's no relationship, or that we found evidence that there's a significant relationship between making your previous shot and then making the next one. However, notice what's kind of interesting is this coefficient is actually negative. So it actually is less likely you make the following shot if you had made the one before. Right? That's what this is telling us. And so we can think about the interpretation. Actually, what was it before so negative 0.005. So we found beta 1 was negative 0.005. So the way we would interpret this is a 1 unit increase in X causes the predicted Y value to change by whatever that coefficient is. Right? So here, what's a 1 unit change? Well, anytime we're dealing with these variables that are just indicators, right? It's a 1 if you made the previous shot, 0 if not. A 1 unit increase for those variables is just going from not making a shot to making your previous shot. So making your previous shot relative to not would decrease the predicted Y value by 0.005. But when we think about a Y value or a dependent variable that's also 1, 0, what that's really meaning is it's changing the probability that you go from that 0 group to the 1 group. So making the previous shot relative to not decreases your chance of making the current shot, or decreases the probability of making the current shot by 0.005. So usually the effect would be in units, but if I have a 1, 0 variable, the units are essentially the change in probability of belonging to that group that is a 1. When I say group here, people who are making a shot relative to those who weren't. Does that make sense? Any questions on that? Because even in your 221, if you, I don't know who you had, even if you had me, didn't really deal a whole lot with dependent variables that are 1, 0. So the kind of unique thing there is now my coefficient is a change in the probability of whatever my Y variable is. Okay? We're okay with that? All right, so, that's interesting, but we left out a lot of other things that matter when it comes to whether or not you make a shot, right? It's not just whether or not you made the previous shot. Are you shooting the ball from half court, or are you 2 feet away from the basket, right? And so just one other thing that we can control for is shot distance. Now, luckily, I already noticed that there's a bunch of, oops, oh, it's not going to show all of them. Oh, that's fun. So I guess we're going to have to scroll down here. So I'm going to use Control Shift, hit the down arrow. Just a good way to navigate so I can get down here to where there's some missing values. So I'm going to select these, Control Shift, Command Shift, hit the down arrow. We're going to delete these observations because we just didn't have a shot distance. I forget how the original data looks. It's something like you get X, Y coordinates. And I think that there's something where some of the data had like some really weird values that wouldn't have made any sense. Like there was like negative distances. So some of them just got thrown out, right? There was just bad data, right? So I think the way that this downloaded was, have you ever seen, so ESPN, I'm sure they do this for like every sport. They do, I think they call it Gamecast, and like they give you like a play-by-play update of what's happening. Well, basically what someone did was they web scraped all of those lines, and then you have a description of what's happening in the games, and you can create all these variables, right? So some of them, they're just whatever reason, there was a bad line of, bad sentence, and they couldn't figure out what the shot distance was. So now that we've deleted those, we go back to data analysis, we go to regression. My Y variable, I'm going to select again since I deleted some of them. So I'll select my Y variable, my X variables. I'm going to select both of them now. So I just highlight both, Control Shift or Command Shift on a Mac, hit the down arrow. Right? That's going to select the entire column of data. I've selected my labels. So I hit OK. Right? Let me blow this up a little bit so we can see this a little better. So now, if we can control for shot distance, think about it this way. Anytime we leave out, and I'm never going to expect you to necessarily write this out and sign this, although like I think if you took 321 advanced stats, you probably would do something like this. But really, when we're running this regression, there is some true relationship between these two variables. We're just getting an estimate. So this beta at 1 hat is like, this is our estimate of what that coefficient is or what that relationship is between those two variables. So what should be the case is if we have a completely unbiased regression, we should get as our predicted coefficient, whatever the actual coefficient is. Because like we only have sample data. I had every shot from 2016, but I didn't have every single shot ever taken, right? And so I'm really just getting like, we don't know what the true population mean income is, but I could go out and get a sample, right? And that would be a pretty good indicator. That's really what we're doing with this linear regression. We're just getting a sample estimate of what that relationship is between these two variables. Okay. The problem is if we leave out other important variables, and this is where I'm gonna have to see if I can do this from memory. So maybe we can check me after class. I might be wrong on this, but it's something similar. So if I leave out a second variable that's important, it would have had a coefficient associated with it as well. And then whatever the covariance was between the variable that I included, x1, and the variable I didn't include in my regression, x2, and I believe this is divided by the variance of x1, we'll get this additional term that's going to bias the estimate that we see, right? So we're going to end up with what we call the omitted variable bias. We've omitted important variables that end up biasing the coefficients. Now, this is just one variable. There's probably like 50 here that are important that I've left out. So I should really look at my estimate and say, it could be way off, right? I need to start including these other control variables. And once I include that second variable in my regression, that bias goes away, right? So that's my goal here. Come up here. So I've got shot distance, and now that's my additional control, right? I just included one. So just throwing in one control, we can see how the results would change. Because now when I look at this shot made previous, the coefficient's actually positive now, but it's not significantly different from 0, right? The p-value is 0.36. I failed to reject the null. And if I'm failing to reject that null hypothesis, well, the null hypothesis was there's no effect. So just controlling for shot distance, well, now we're looking like I've eliminated that bias that existed. Now it looks like the actual relationship between making my previous shot and the current shot, there is none, right? It's no different from 0. Okay? Now,
thinking about, you can sometimes think about what variables might be important. So in this one, if I make a shot, maybe I get a little bit more confident. Maybe my subsequent shot, my next shot, I take a little bit further from the rim, or I take a little bit more difficult of a shot because I've got some feeling of confidence, right? And so maybe if you exclude shot distance, what that previously making the shot is going to look like is that it's negative, because it's not that making that previous shot had a negative impact, but it was that making the previous shot made you take harder shots, right? Or shots further from the rim, which if we look at the data, we know field goal, the chances you make it go down the further you move away from the rim. If you just looked at the overall data. So it's kind of interesting. Also, not that surprising. As I move further from the rim, I believe shot distance here was measured in feet. No, maybe it was tenths of feet. Let's see. Oh, never mind. I had it on here. So if it's 0.1 to 20, yeah, I'm guessing these are actually actual feet, right? So if I move, if I move 1 foot, 1 unit further from the basket, the probability that I make the current shot goes down by about what, 0.01, so about 1%, right? That's the probability. So in percentages, move that decimal 2 places. And here, the p-value is so small that Excel just shows us 0. So Excel has its limitations. The p-value isn't exactly 0 here, but it's so small that Excel rounds it to 0. Okay. Any questions on anything up to this point? Just kind of walking through an example, thinking about how we would do this in Excel. So I'm going to go back to the original data, and I'm going to select all of it once again. So Control Shift, hit the over arrow, hit the down arrow, right? Copy it. Oh, I hit the shortcut for copy, so it should work. And then whenever you go to paste it, I always just use this paste values, just in case you've used any type of like formula or anything. You just want the data. So I'm going to start to eliminate some of these things. So maybe I want to control for the total seconds remaining in the game, right? Maybe there's some type of pressure aspect to the game. I probably don't really need anything over here. So I'm just going to delete this just to kind of make our, actually, we might want to control for the period. So let me do from player to date, actually player to play length. So we'll delete this. And actually, I'm going to turn the filter on before I forget and do something that screws this up. So I turn my filter on. I'm not going to control for any of this. So I'm going to delete these variables. I've got shot angle. I've got shot distance. I've got what side of the court it was on. Got another shot distance measure. So I think, oh, this was the one that wasn't in feet. That's why. So we'll keep the one that was in feet. It makes it a little bit easier. I've got the attendance. I've got whether or not the player shooting was on the home team. Total points here. I think I've got the point gap. So we'll just keep the point gap, how close the team was, right? If they were, this one was up by 2, here they were down by 4. So we'll kind of get rid of these variables. And now I'm thinking about, okay, guys, a little bit smaller data set. I don't just want to throw the entire kitchen sink, like just because I have variables in my data set, like even the ones I'm sending to you, doesn't mean you need to use all of them as control variables. Right? Some of them just may not be relevant to the question, right? It'd be like throwing in, what would be a good one? Throwing in whether or not there was a rebound 5 minutes prior to the current shot. Okay, why would that necessarily matter? There's no reason to start creating these variables and throwing them in as control. So we've got a pretty good set here. Now we're going to have some issues with some missing values. So I'll show you one way that is kind of quick to identify this. You can just use the filter options and look for the blanks. But one way to like quickly identify which ones are going to be a problem, if you do this count blank, right, function, and then Control Shift, hit the up arrow, we'll notice it's going to select all the way the entire variable. So hit enter. And it tells me basically the number of cells that don't have a value in it. So this will tell me if I'm missing values for these variables. So once I do it for the very first variable, now if I just copy it over, because I was using those cell references, it updates every time I copy it over a column, it updates the cell reference column. So now I can find, okay, here's my problem variables, right? Here's the one that have missing values, right? Now this data set wasn't so big, it'd be a little bit easier to remember what columns these are in, but I think hopefully I can do a good job here. So starting at E, we're gonna deselect everything. We only want to see the blanks. So I'm gonna go all the way over, holding Control Shift, just using my arrow keys. Hit that down arrow. Right click, and where is it? Delete all these rows, right? Because that's just not usable data. If I want to include all these things as controls, I can't use ones that have missing values. Yep.
Why don't you just hide the blanks and only show?
So if you hide the blanks, when you use that regression analysis tool, so when you filter this so that you only see certain things, notice the very first, well, it's struggling here because I hit delete and there was probably a lot of observations. So let's see. Did I freeze my computer up on accident? It's trying. So I can explain to you. So you can kind of see here. See when I filtered it, the first row looks like it, of course, now it goes away. So, well, it said 162. So it's not that. So the other rows are essentially there. They're just hidden from your view. They're still stored into the file, like the regression analysis tool will use the entire data set there. And so just because you can't see it, it's still using those observations. Yeah, so that's the only reason you can't do that. Yep. Other programs, like Excel is somewhat limited, but I don't expect or have the time to teach you guys something like SAS, Data, R. But a lot of those other programs, once you get kind of to the next level outside of Excel, if you're doing regression analysis, it just can ignore those missing data points and like store them in a separate file so that it's only using things without missing values. But Excel doesn't have that capability. So we have to make sure we get rid of them. So go back here so I can show everything. Height in inches. Probably should get rid of those zeros as well, but I'll not worry about that too much. So I don't think there's anything here. Was it shot distance was the other one? Okay, and this was the one that was kind of a problem. So if you do have a variable, actually no, we can see the blanks here. So I'll deselect everything, hit my blanks. Okay. I'll then select all these that have blanks. So we'll delete these. So sometimes it can be a little bit cumbersome of a process, especially if you have a lot of variables. I should have dropped all these before I did it, but I wanted to show you how it is, like how you can get rid of these missing values. I just should have probably only left one variable in here, so I didn't have to do it for all of it. I'll give it a little bit of time here. So if you have a really big data set like this, sometimes doing this in Excel can take a little bit of time to load. So just be aware of that. I don't think I've given anyone too crazy large of a data set, but if I did and you're having issues with it, let me know. We can kind of trim it down. So let's show all the observations again. And then hopefully shot made previous is the last one. Why is there a 4093? We're gonna get rid of that one because that must have been a coding error. So Control Shift. Oh, looks like that was something bad in there. That we'll go delete. Okay. And then this will take a little bit of time. Then once we have this, we should be able to kind of run our regression. We include a bunch of different controls, right? So you can imagine like there's a bias that exists from every single other variable that matters that we didn't include in our regression. So if we can include all those, hopefully we can eliminate all of this bias. So we're waiting. Let's see, hopefully this doesn't take too long. It's never good when you see the not responding up here, but we'll give it a second or two and hopefully it works itself out. Is there anything else I want to point out in the meantime? So one thing we can think about is our Y variable here was whether or not the shot was made. And then we basically want to include every other variable here as a control other than game ID. I don't know why I didn't delete that, but we just kept that in there. And so the issue becomes when we're trying to do this regression analysis, I can't select columns unless they're all right next to each other. So unless they're adjacent. So because my Y variable is kind of in the middle of my data set here, that's going to present some challenges to me. So what I need to do is essentially just move these columns so that my dependent variable is all the way either on the right side or all the way on the left side on its own. And then all my control variables are right next to each other. So if this hopefully responds here soon, we can move these around. I don't know why it's taking quite this long. Maybe I underestimated the size of this data set. All right, well, 4,000. Give it a little bit longer to see if it pops up. If not, I'm just gonna restart this. Okay, we'll restart it. I did not anticipate this issue. I apologize. Yeah, well, apparently it still left a lot of it in here. Let's see. See if I do this one more time, if I get some issues. I hope this goes a little bit quicker this time. Yes, we'll delete everything. I got an idea. Let's do these. Let's do these a little bit at a time. So we'll just select about half of them and see if it likes it a little bit more. I think this might be a little bit better. Oh, because I really wanted to show you how to do this with all these variables, and so unfortunately we may have to come up with a different solution. Yeah, I don't believe I gave anybody over like a couple 100,000 observations, so hopefully you won't run into this issue with your data set. You know, if you're only having even a couple thousand, it should be able to do this with no problem when you're deleting these missing values. If I had thought ahead of time, I just would have deleted these just for this variable and only shown you how to do it with other ones.
So
Yeah.
when you run the regression
Mm-hmm.
and it gives you p-value,
Mm-hmm.
is that for one tail or two tail? If it's two tail, what would you divide it by two?
Yeah, so the way that, so as we're waiting for this, hopefully it's you can think about it as if our null hypothesis, everything we're going to do in this class, you can do stuff with a regression where you do one-sided tests, but it's pretty rare. So we're always really assuming that it's equal to 0. So it's always a two-tailed test. So the regression results that Excel gives you will always be for that two-tailed test. So it's giving you like, you know, if we go back to ECON 221, if it was one-tailed or if it was only giving you one side, you have to multiply by 2. You don't have to worry about doing any of that. The p-value it gives you, it's already accounted for that. That's a good question, though. All right, well, we may not be completing this unless I can get this to work here. Oh, come on. All right, let's try this one more time. I think I have an idea for how I can do this. Kind of cheat. See if it opens up where we left off. Okay. Let's get rid of this. Pull this up. So I've got a kind of a cheat way to do this. So let's just arrange these from smallest to largest. So now when I go to my data analysis, I've made sure all the blanks, this was the only other variable was because we had this previous variable that we were missing some stuff. So I'll go down here to regression. And what I'm going to do is for my first one, I'm just going to select this shot made previous variable. And it's basically going to show me where the missing start, right? So now this cell reference will be basically everything past that. I just am not using in the regression, right? So just so I remember this, I'm going to copy this here, exit, cancel, go back up to the top. So just so I have this stored somewhere so I can use it, because I still need to move these around. So what I was saying before was this shot made variable was our dependent variable. So if I come up here to the column and you see how they get this black kind of arrow, if I select the column and then move this over to the side, and then I'm going to hold and select all of the columns and then just move them over one, right? So now my data is still filtered and I've got all of my control variables here on the left-hand side that I wanted to use. Excuse me. So now I'll go to my data analysis. I'm going to keep it over here. And actually, before I do this, I'm going to copy this. So data analysis, regression. So our Y variable was right here, right? But it's in column P. So I know the range. So I'm just going to go instead. It's the variable that's in column P here. And then for the other one, I'm basically going to select everything else other than the game ID, Control Shift, hit the down arrow. Okay, it sent me to where I start seeing, starting to see missing values. Oh, come on. This is how much of a pain it can be to work with data sets sometimes. So it looks like this has some missing values too. So let's sort these as well so that we get all of our missing values at the very end. Now, if I go down here, it's not going to have these. Well, that's fun. All this may be after something I showed another time. Let's just get rid of this variable then. It's going to cause us some problems. So I'll go back, sort the shot made previous. So all of them are at the end. Now when I go to data analysis, regression, I go to select my Y variable. Actually, I think now I should be able to just select shot made. Except for that's going to take me all the way down, but it's okay. Then go to select our X variables. Select from period all the way over to point gap. Hit down. Now this selected all of our missings. So what I'm going to do is just scroll and find where these stop. So I'm going to cheat a little bit. See if we can get there relatively quick. Oh, I just went past it. So it looks like the last cell that has a non-missing value. This can take some time. So let me see. Oh, we're getting close. Well, I'm just going to choose some point. So we'll say 21500. So 21 million. Wait, that can't be right. Sorry. 363,392. So 363,392. So I'm just going to choose an arbitrary place to stop so we can get this. And I'm going to say, okay, let's make sure. Come on. Three, 392. So we're starting and stopping in the same one. So now I've included every single variable here. So now
the interpretation becomes a lot cleaner, right? Because now when I'm looking at that shot made previous coefficient, I'm saying holding constant the period of the game, period is just the quarter of the game, the total seconds remaining, the minutes remaining in the quarter, the weight, the height of the eventual, the attendance of the game, whether or not the player was on the home team, the shot distance, all of these things, right? I can control for all of them now. Oh, what didn't it like? 363, 392, 363, 392. Selected my labels, 0, 0, 0 to, or B to N. Oh, come on. 363, 392. And what was it telling me? Please check input ranges. Probably what? Yeah, I'm guessing maybe I've blanked. Well, all right. So we didn't get this one. I'll bring this data set a little bit more cleaned up on Tuesday. But you can imagine the idea if I have none of these missing values in there, if I could delete them the way I was showing you, it doesn't take forever. We could basically throw in every single variable that we wanted. And now the interpretation becomes holding constant all these other things, but the previous shot was made. Now it's the impact on the probability of making the current shot, right? So including as many control variables as we can is always desired, right? We always want to be able to use as many as possible without just throwing in ones that we don't think would have any effect at all. But you know, just from that one, let's see, where was it? Was it sheet 3, sheet 4? Just from including one variable, you can see how it changes the coefficient. So if we start to include a bunch, we might get some dramatic changes in this coefficient that we're seeing, which would then alter, you know, our decisions kind of moving forward. So I kind of already told you about moving those around, showed you how to delete some of those missing values. So I'll show you how to do one thing that could be helpful. So I'm going to delete these empty sheets that we're creating. And yeah, we'll look at this. So let me think. So this period variable, right? Or this, like what quarter of the game it is. When I include this as just a single variable, it's treating it as though the effect of kind of going from each quarter is linear, right? But maybe there's very different effects going from the first to the second, and then going from the second to the third, and then third to the fourth, right? So maybe it's not that it's completely linear. And so what I could do is actually create just indicators for what quarter of the game I'm in, okay? So maybe here, I want to just create a 1-0 variable that would allow for it to not be a linear function. So I guess I'll give you a little bit visual before we go into the. So maybe I'm thinking about that shot made variable. I've got some intercept. And what I had done before was kind of think about, I just included some measure of what quarter it was. So this could be 1, 2, 3, or 4. But that forced that relationship to be linear. And so, and if it wasn't quarter, for instance, maybe I want to like include a control for what team the player was on. So that's not even a variable I can include because it's a word, right? What I can do is create indicators so that instead, I create 1-0 variables for, was it quarter 1? Was it quarter 2? Was it quarter 3? And I'll show you a problem. You would think that you would just include every single possible one. But then what's your base group, right? So the change in the predicted shot, you know, in the probability that you make the shot from being in quarter 3 relative to what? Because there's controls for all the other quarters. So relative to not being in the game, it doesn't exist. So what we're going to have to do is end up leaving out one of these groups so that we have one group as our control group. Right? So anytime you have something where you're trying to turn a variable into these separate indicators. So maybe I had like a NCAA basketball one, and I want to control for what conference the team was in. Well, I can create all these indicators, one for every single conference, just a 1 if that player was on a team in the Big Ten, 0 if not. 1 if this player was on a team in the SEC, 0 if not. But I have to leave out one conference because otherwise I don't have a comparison group. So I can create all these indicators and include them in my regression, but I have to leave one of them out.
So we'll see what this looks like in Excel here. So I'm going to delete this. So we've got quarter one, quarter two, quarter three, and I'll show you what happens if we include all of them. So one thing you can start using is, and I'll zoom in. I just realized that the view is a little bit small. So one thing I can do is use this if statement, right? So if is a built-in function in Excel that checks to see if a certain condition is true. We then tell it what to put in the cell if it is true, and then we tell it what to put in there if it's false. So I'm going to go over and select my variable that was period and say, okay, if this is equal to a 4, no, sorry, this was quarter one. If this is equal to 1, comma, if that's true, put a 1. If it's false, comma, put a 0, right? So this was not in the first quarter of the game, but once I have that entered in there once, if I copy this down, it'll keep updating so it checks to see for every observation what quarter, if it was in the first quarter. So when I get this black plus sign here, if I double left click, it's going to do this for every single observation. Okay. So I now have an indicator or an identifier for was the shot taken in the first quarter. I'm going to do the same thing. So I'm going to use the same variable, which was the period of the game, and say, okay, if it's equal to 2, comma, put a 1, comma, if it's not, put a 0. Okay. Then I'm going to do this for the other quarters. So if, I think it was what, so B, so if it's equal to 3, comma 1, comma 0, and then equals if that cell B2 is equal to 4, comma 1, comma 0. Did I put B3 here? No, I put B2. Okay. So now I'll just highlight all of these, double left click, and now I've got this for every single observation, what quarter it was in. So now if I go to my data, actually one thing I'm going to do, just going to grab one of these variables that we know works. So we already used, let's use height and weight here. So I'm just going to copy these, put them over here so everything's next to each other when I go to run this regression. So I go to data analysis, regression. I'm going to select this shot made variable. I'm then going to select the quarter variables and the height and the weight of the player. So I'm going to select all of these, hit OK. Oh, isn't it like? Oh, all right. Oh, here, let me see. Actually, I should be able to just do the shots. Let me see. We'll just select the quarter variables here. That should be everything. They start and stop in the same. Yeah, there we go. So it must be an issue with that height weight variable. So we'll zoom in here so we can see this. So here, I include an indicator for every single quarter, right? And it runs okay. So what would my comparison group be here? Why does this work? What did I leave out? It's a little bit tricky. So it's not playing, but what happens if it's tied at the end of the fourth quarter? I get an overtime one, right? So maybe I go back here. What was it? Where was our sheet data? Here we go. And I say, okay, look at this quarter variable or this period variable. Oh yeah, it goes way higher, right? So I'm actually going to show you, even if we did include that, what would happen. So don't worry about this too much. I'm doing this a little bit quick, but we'll use that if statement and say, if it's greater than 4, comma 1, comma 0, this will indicate games that went to overtime, right? Or sorry, shots that were taken in overtime. So because I wanted to show you what happens if we included all of them. So if you're thinking about the control group being someone who's not playing in the game or, not playing in the game, the problem with that is, so if I selected indicators for each quarter and then whether or not it was in overtime, I don't have a control group and it gets mad at me, right? So sometimes this will run and it will just leave out like one of the variables in the regression output will just like have pound sign num, and it'll be like some blank stuff. So it'll drop one of those groups for you, but really in practice, you should leave one of them out
so that your comparison group now exists. And now this is the effect of taking a shot in each one of these quarters relative to taking a shot in overtime. So this gets a little bit tricky to think about, but here, notice all my p-values, anytime I see this e to the negative, that means move the decimal that many places to the left. Anytime you see Excel with the p-values default to like scientific format, this just means the p-value is basically 0. I mean, it's right. So 1.5, move the decimal 10 places to the left, that's 0.00000001. It's basically a p-value of 0. So anytime you see the scientific format come up, you should know that variable definitely has a significant relationship, right? Because the p-value is basically 0. So we can reject at any level we want. Now, the interpretation of the coefficients here, they're all positive, right? So this is going to be the change in the probability you make the shot relative to what? Well, it's the group we left out. So if I take a shot in the fourth quarter, relative to taking a shot in overtime, there's about a 4% chance, or a probability increase of about 0.04 that I make the shot. So what's the fact that all these are positive? So relative to overtime, all of these, we should see an increase in the probability to make the shot. What might that lead you to believe about shots taken in overtime? They're tired, maybe there's more pressure, right? This is telling us that you're less likely to make that shot in the fourth or in overtime relative to the other quarters. Or said differently, because overtime was what we left out, you're more likely to make the shot if it's taken in any other quarter relative to overtime. Right? So anytime you've got like a variable that you want to turn into these indicators, so here I turned that quarter variable into the indicators for what quarter it was in, you've got to leave out one of them, and that's your control group. Right? Any questions on that? Okay. So I think that's about, I wanted to just kind of play around with some of this data. You can see even today, I ran into some problems, right? If we're missing some values. So sometimes it takes a little bit to clean up. I try to clean up your data that I'm sending to you for your project as much as I possibly could. So I tried to get rid of any of this missing value stuff for you ahead of time. But I also did want to show you in case I did leave something in, or you went and got some additional data that you can kind of deal with those missing values. So the other thing that I want to go through is this paper, because I think it's relatively interesting. It just gives us a little bit more, we can start thinking about a little bit more about linear regression. So the idea of this paper was basically, do high school athletes get better grades in the off season, right? Or during the season, do they get worse grades, right? And so I actually went to grad school, this person, but they looked at, I think this was almost all Indiana data. So we can scroll down here to their data section. So she didn't say this, but Midwestern high schools means primarily Indiana, some Illinois, I think a couple maybe Ohio schools or something she got in there. And so we're looking at kind of high school data, and the question becomes, let's scroll down here and see if we can find the regression equation. So right here, so she was looking at GPA measures. She included a bunch of control variables. SC was what? School lunch. So she was trying to control for kind of the economic conditions of the school that the student belonged to. And then basically this athlete variable was a 1 if they were a student athlete, a 0 if not. Okay. So here, once again, we've got a 1, 0 variable. So the 1 unit increases going from being a non-student athlete to being a student athlete would have whatever. This is gamma, but this is our coefficient. I don't know why sometimes when we write these things, I always use like beta 1, beta 2, beta 3. Some people just start using different Greek letters. But, right, this is going to be the expected increase or decrease in GPA from being a student athlete relative to not. Okay. So we'll scroll down then to find their first regression output. So here it is. And they don't show you all the variables they included. So notice they included controls for what year it was. So that's the same idea when I showed you with the quarters. You could take this variable of what year was it and create indicators for, was it 2009, 1 or 0, 2010, 1 or 0, et cetera. Right? So, controlled for what sport the person played or sports they played. Included indicators for different school grade combinations, as well as different year and grade combinations. So really trying to control for as much as possible, like any effects that could vary across schools, across grades, and across time. And then what year in school they were, a male indicator, and then the one that we're really focusing on, which is this athlete variable. So if we run this simple regression, it looks like being a student athlete actually has a pretty positive effect on GPA. So this has actually been a question that a lot of people have is, when you play a sport, it takes quite a bit of additional time, right? And so maybe it has a detrimental effect on a student's academic performance. But also, relative to not doing anything at all, being in a sport might teach you things about time management, might teach you things about, you might just be more motivated to do well in school, to stay on the team, even if you want to think about it as cynical as that. But there's all these potentially, skills that we can't measure that might actually you pick up from playing that sport, teamwork, like working with others, that might translate into better academic performance. So here it looks like maybe that's the case, right? But a little bit more of a deep dive, it kind of shows this is a little bit more complicated of an issue. And so here, this was just whether or not they were a student athlete at all and their GPA over the entire year. So you might think that, well, while they're playing the sport, there might be very different effects than when you're not playing the sport, right? While you're playing the sport, those impacts of not having as much time, right, might actually have a detrimental effect on your grade. Whereas if you play a sport, but you're currently in a semester where you're not, well, all those skills that you learned, right, time management, et cetera, maybe those are now having a positive effect because you don't have this additional negative impact coming from the fact that the sport's taking all of your time. So in or out of season, being a student athlete might have very different impacts on your GPA. So the next thing that they do, we'll scroll down here. I thought it was relatively quick. All right, here we go. Here we are. Oh, nope. I forget she has a bunch of tables in here that don't really matter. All right, here's our baseline results, right? So then what she does is, okay, I'm not just going to include an indicator for whether or not you're a student athlete. I'm going to include an indicator for, are you a student athlete? And then separate GPAs out by like semesters, right? So am I in a semester where I'm playing the sport, or am I in a semester where I'm not playing the sport, even though I'm a student athlete? So here, the indicator for in-season effect is this a semester that I'm currently playing the sport that I play? Or am I currently playing a sport in this semester? And there it looks like the effect of being in season, looks like there's some positive effect on math, but everything else, so these stars represent that it was significant. Every other estimate we had, so their change in their core GPA, change in English, change in the total, we didn't see any real effect there. So maybe there's a positive effect on math GPAs from being in season. Now, this is a little bit odd and a little bit inconsistent with the rest of the results, but we'll kind of come back to this. So that's where our starting point off. Why this is the case? Why does it occur in math and not English? There's no real explanation here from the data. And so we come down here and say, okay, maybe we need a little bit more analysis. Let's break this up even into like JV and varsity. Because, JV doesn't have maybe near the time requirement. It's not taken as seriously. Maybe there's some varying effects. So now we've got these indicators for, is it a semester where I'm on the JV team? Is it a semester where I'm on the varsity team and playing? And then here, this varsity control is just, am I on the varsity team or not, right? Doesn't matter if it's in or out of season, okay? So here, just being on the varsity team looks like we've got some negative impacts on the student's GPA. However, when they're on varsity and it's currently in the season, we actually see that the change in GPA is still negative, but we actually start to get the math one isn't quite as negative. It looks like there's more of an impact on English. And so these aren't the most consistent impacts, but it's starting to look like it doesn't matter if I'm in season or not, being on the varsity team is having some negative impacts on my GPA. Like not everything is significantly different from zero, but a few of them are, right? So we're starting to get evidence that being on the varsity team, whether you're in or out of season, is having a negative impact on that student's performance. But however, if we look at that JV variable, even when it's in this like current semester of when you're playing, the GPA actually changes are actually positive here. So it may be something about if the time requirements to play that sport aren't really, really high, such that they would have a negative impact on your grade, that these additional skills that you're learning from just being on a team might actually have a positive impact on your academic performance. So it's not simply playing a sport or not, the level matters as well. And that's really because, you know, the main argument about finding a negative effect from playing a sport, whether this is at the collegiate or the high school level, is just the time requirement. And so here we've got a way to look at two different types of playing a sport with different time requirements, JV versus varsity. Any questions on this before we keep moving here? So just more discussion about some linear regression results and thinking about kind of an interesting question here. We scroll down, I believe there's one more table I wanted to look at. So she does some robustness check stuff. We don't have to worry about any of this. Okay, this here it is. So this is kind of interesting. So we're controlling for a lot of other factors. So instead of GPA, they then look at a different dependent variable. So one of them is, what was the ease of the courses they took? And I forget how they exactly came up with course ease. It was something like looking at the pass rates and the average grade in these different courses, and then kind of saying, okay, what was the overall measure of ease of the courses that this student took in the semester? And then they also had what their pass rate was, right? Were they more likely to pass a class when they were in season? What they actually found is, you know, it's not significant, but maybe some evidence that being in season, taking slightly easier classes, although like we can't say this is any different from zero because it's not, the p-value is too high. But the pass rate, what's interesting is being in season made it way more likely that they pass a class, right? So if we're just looking at every single class they take, yes, sneeze. Okay, maybe not. So, you know, here the analysis isn't semester by semester, but it's course by course, right? So it looks like students that were currently in their season or currently playing a sport, their pass rate actually went up. So this might be the indicator that, you know, some people are just trying to remain academically eligible. You know, you could probably argue maybe there's some favorability going on from the teachers, depending on, you know, what sport. Really interesting to look at what this effect would be like just for maybe football, and then just for maybe like, I don't know, with volleyball, right? And see if there's differences in this effect, which might be an indicator that maybe some of the teachers are being a little bit more lenient, right? But it could just be this is purely being from the effort of the student as well, right? To remain academically eligible. And they controlled in here, I think, school semester, income proxy. So yeah, so one thing they didn't include for here, which blows my mind, unless I'm missing it, but it would make sense to me to also control for like the previous GPA of the student. That way you have some measure of like the quality or academic quality of the student, but kind of interesting results, right? So we see that, you know, maybe playing a sport, if we don't break it up into different levels, it looks like there's a positive effect. But once we broke it down into the varying levels of time commitments, we can kind of see that, well, really what we're picking up is there's a positive effect for these JV students, but the effect of playing a sport for the varsity students actually looks like it's negative, right? And maybe, you know, on the core GPA and stuff, maybe it's not statistically significant from zero, but we're at least seeing some evidence that it could have negative effects. Any questions on this? Keep moving here. I think this is actually all I wanted to get through today. So hopefully, I don't know, just seeing kind of more things done in Excel and talking a little bit about regression will probably be something that happens a little bit more in the second half of this course. We will on Tuesday pick up on kind of where we were left off on Tuesday, thinking more about the labor market, some issues that can arise. And then I doubt we'll get there Tuesday, but Thursday for sure we'll start looking at discrimination. And so I've got an idea of another data set, and I promise I'll try to clean that one up a little bit better for Thursday, but we'll have maybe some like race identifiers for players and look and see if we can think about how we could use regression to pick up whether or not discrimination is occurring, right? And then we'll kind of start to talk about topics theoretical related to discrimination in sport and how we can identify that. Okay. All right, so hopefully everybody is able to go out now and enjoy the nice weather.
before it starts raining tomorrow. Have a fun, safe weekend, and I will see you guys next Tuesday.